the center of galaxies, that's on the low end, because we think about things that are 1 million to 1 billion times the mass of the sun.
And for 1 million solar mass black hole, like how, like for the sun, maybe start simple. If the sun was turned into a black hole, what would its radius be?
It would be about the size of college campus.
Now, it depends which college we're talking about.
Let's talk about NYU.
Good. So a couple kilometers across.
Right. Yeah.
For the one in the center of the galaxy, how big do we think it is?
It's about 10 times the size of the sun, so about 10 million kilometers.
Wow. So it's a big object, but it still follows the same basic pattern that it has an edge, an event horizon, and all the standard lore would apply to it. It's just on a bigger scale.
Right. It just scales simply with math.
Right.
With math. So the
Good.
math is simple.
Yeah. So what evidence do you have that it is a black hole? Can you sort of take us
I can film it. You can see behind the sun
So
coming.
to prove that there's a black hole directly,
They
what
don't
you
want to tell
do
people
is you want to,
because people get afraid.
You want to show that
So,
there's a lot
look
of
at the
mass
weather.
inside a small volume.
Something
or
is coming
inside a
to
small
this planet.
region. In particular, you'd like to show
I'm
that
telling
it's
you.
confined within its
I'm
short
not
shield
lying.
radius that you were.
That's why they're blocking off the sun.
Is the radius for a given mass, where if you can
And
cross
they
the mass
block off the
within
telescopes,
that radius,
man.
it will naturally
The CIA
turn
was
into
there
a
also.
black
Remember
hole.
the
Right, and so that's what
shit.
the size that we're talking about, because of course the black hole itself is infinitesimally small.
Oh my
so
God.
this isn't the abstract size, and so
I think
our
we
job
get a flip.
Just clarify that.
That's why
You
the
said
pole
that you're
shifting and the
talking
planes
about
falling out
when
of
the
the
black hole
skies,
forms, the
man.
matter crushes down to a small size.
That's what I think.
Yeah, so the idea of the short shield radius, or is that no light can escape it, as we were just talking about.
I don't understand
but
why
it's
they're
also true
selling.
that once you get the mass to that scale,
They don't say the truth,
gravity
man.
will overcome
They know
all
there's coming
other known
something.
forces, and there's nothing that can stop the collapse of the object.
Oh.
So from a scientific point of view, once you've shown
Look
that
at
a
her laughing.
mass
I
is
also
within
know
its
something is
short
coming
shield
to this
radius,
planet.
you have come up with the proof of a black hole. So from the point of view of somebody who's hunting for black
It's
holes,
standing in the
your
Bible.
job
It's
is to show
everywhere,
that there's
man.
some amount of mass inside a small volume.
Oh my
So the
God.
way we've approached it at the center of the galaxy is to look for the stars that are at the heart of the galaxy.
You never went to the
and
moon,
to
man.
develop techniques that allow us to not only see the stars that are that close, but that allow us to observe how they
They
go
don't
around the
understand.
center.
They're living in a
So
matrix.
if you want to find the center of the galaxy, you can look up in the night sky and find the constellation of Sagittarius.
shit.
It's the teapot, and the teapot pours into the center of the galaxy.
Is that right?
That's your road
So
map.
convenient.
So convenient. And if you look up at the night sky, not in, of course, New York, but in a place that you can actually see the night sky, you can see the Milky Way. And the Milky Way is that band of white light that comes from the stars. But there's also a lack of light, which is from all the dust. So you can't actually see the center of the galaxy at wavelengths that your eye detects. So a key to the work that we've done is to use infrared technology. So looking at light that is just longward of what your eye detects, maybe where a TV remote control works.
Yep.
And that allows us to see the stars that are at the center of the galaxy.
And what have you found?
And we've found that they go, well, one, that we can see them, which is rather amazing, and that they go around the center of the galaxy quite fast. So my favorite star in the galaxy, its name is SO2, goes around every...
What's its name again?
SO2.
Okay.
It probably needs a better name.
Yeah, it's real catchy. Yeah.
So if you have a better name...
We'll leave it to the audience to figure that out.
But you can use actually Newton's laws of physics to show that if you go around every 16 years and you measure the size of the orbit, which is about the size of our solar system, that shows that there's about 4 million times the mass of the sun inside this incredibly small region. And to give you a sense of the change of our knowledge or our understanding of what resides at the center of the galaxy, we've increased the density of dark matter by a factor of 10 million compared to what was known before our work. So in a sense, we've advanced the case for the existence of supermassive black holes by that amount. I mean, think about anything in your life that you'd like more of and being able to get 10 million times more of.
Right.
And that's what's happened at the center of the galaxy.
Right. So the basic argument, as I understand it, is you're tracking these stars, and their motion can only be explained if there is a black hole of that mass residing in the center of the galaxy.
You're basically weighing what's at the center.
So is this actual data?
This
here?
is data. This is the real thing. So we've looked at two versions of it. One is the flat version, which was playing just a moment ago, and it showed my favorite star. And this is actually a bigger view of the data that we've taken over the last, and I can't believe I'm saying this, 25 years.
Have you been involved with it since the beginning?
This is my baby.
It is.
Oh yeah. So in fact, it's interesting to reflect back, because when I first proposed this experiment, when I first got my job at UCLA, I thought I had a good idea. It was actually turned down. They said the technique wouldn't work, and even if it did, we wouldn't see stars, and even if we saw stars, we wouldn't see them move. So it was a lot of no-no-nos.
Right.
And in fact, we were asking to do a project that was only 3 years long, just to see that stars were moving fast. No one anticipated that they would move so fast.
How fast is fast? Just to give it.
Like
my
3 million
God.
miles an hour.
They don't know what it's going to.
They're hauling. And it's it's rather remarkable that we can measure something on a human
Why do you
time
think
scale.
the weather has changed everywhere?
And so as this project has gone on, and maybe we can talk a little later about what it takes,
And
the
displaying the
technology
sun.
has changed so much that
Because if people know about this shit, they understand. They never go to the jobs again. They're gonna flee like
so this
around
three-dimensional
like
animation
ants,
actually
man.
shows the kinds of stars that we see at the center of the galaxy,
Oh
and
my God.
almost every single prediction for what we should see near the black hole is inconsistent with
Oh
the
my
observations.
What does that mean?
That means
Yeah.
it's job security.
Yeah.
So you're
For
trying to
Jabba
figure it
there,
out.
she's going on the ground.
But it's not inconsistent.
She knows exactly
yet
what
with,
is going
say,
on.
the general relativistic
She's
prediction.
going
No,
on the
so
ground.
there's both the physics side of this work, where you're trying to ask physics questions like, do supermassive black holes exist? How does gravity work near a supermassive black hole? So where we are today is that we can or at least in my opinion, we can definitively say that the supermassive black hole exists, and then the where we are actually we are still in the middle of
Tell the
this.
truth.
Can we test Einstein's theory of general relativity?
And that is what you're doing now, if I understand. Like, we're in actually a special time at this very moment, right?
Yes, we're in such a special moment. I can't believe I'm actually sitting here as opposed to being in Hawaii, where we take all
Well,
the
thank you
data.
for taking the time away. But tell us,